Okay, Bismillahirrahmanirrahim. Today's topic is heat capacity or thermal capacity. Class 9th Physics, chapter number 8. This is also another very important topic, and it is very interesting topic as well. The definition of this heat capacity or thermal capacity is the quantity of heat required to raise the temperature of a substance by 1 Kelvin or by 1 degree centigrade. Here the mass will be any mass, 1 kg, 2 kg, 3 kg, any mass. So, but we have to increase the temperature by 1 degree or 1 Kelvin. So that will be called heat capacity, represented by Cm of that substance. Mathematically that is given Cm is equals to del Q divided by del T, and that will be explained here in detail as well. Similarly, the Cm value, the heat capacity value, depend upon the following factors: nature of the material, mass, and rise in temperature. That will be explained here as well. Similarly, another thing is specific heat capacity. The specific heat capacity means the same definition is written here, but the only difference is 1 kg. So the quantity of heat required to raise the temperature of an object by 1 Kelvin or 1 degree centigrade, but having 1 kg mass. So that is called specific heat capacity, and that is represented by C of that substance. Mathematically, C is given by Cm by M, or C is equals to del Q divided by M del T. And similarly, the unit of heat capacity joule per Kelvin, and here the unit of specific heat capacity is joule per kg per Kelvin. There are diagrams. I will explain them in detail. Okay, the first thing is heat capacity. Heat capacity. Heat capacity. What does it mean? As the definition written here, if we have a substance of any mass, look at here, we have a substance of any mass. This is any substance, anything, any material made of iron or copper or aluminum or any material it may be, and its temperature is 19 degree centigrade. So this material of any mass having temperature T is equal to 19 degree centigrade. If I give heat to this material, and the heat that I am providing to this material, and this heat is absorbed by this matter or this substance, so this heat absorbed and the temperature of this material is increased by 1 degree centigrade or 1 Kelvin. So the temperature here is 20 degrees centigrade or 20 Kelvin. So this heat absorbed or this increased in temperature by 1 degree or 1 Kelvin is called the heat capacity of this substance. So the heat capacity means that how much heat is required for an object to increase the temperature of that object only by 1 degree centigrade, only by 1 degree centigrade or 1 Kelvin. So we say that any mass of any object for which we increase the temperature by 1 degree centigrade or 1 Kelvin, that will be called heat capacity, and that heat capacity is represented by Cm and is given by del Q divided by del T. So it may also be defined as the ratio of the heat to the temperature, ratio of change in heat to the ratio of change in temperature, and the unit may be formed from here as the unit of the heat is joule and the unit of the temperature is Kelvin. So it may be written as joule per Kelvin. Now the other thing that we have just discussed here, that is the value of Cm depends upon the following factors. Nature of material. So the nature of the material, for different materials the heat capacity will be different. If the nature is changed, the heat capacity will be changed for those materials. Mass. Similarly, if we have 2 kg mass, the heat capacity will be according to 2 kg mass, and if we have increased or decreased the mass, so the heat capacity will be according to that mass. And the rise in temperature. Similarly, the rise in temperature is also another factor upon which the heat capacity is depending, because when we increase the temperature or decrease the temperature, the heat capacity will be affected by that factor as well. Similarly, another thing that is specific heat capacity. Now, specific heat capacity and heat capacity are the same things, but the only difference is I am mentioning here. Here we have of mass m, and here we have of 1 kg mass. So if any mass is there, so that is called heat capacity, and if the mass is only 1 kg, so we will say that that is specific heat capacity. So the specific heat capacity is defined here, the heat required to raise the temperature of 1 kg of mass of a body by 1 degree centigrade or 1 Kelvin is called specific heat capacity, and that is represented by C. C is equals to Cm by M. So here I must explain that as well. Specific heat capacity. As the diagram shows the specific heat capacity here, if we have a substance having mass only 1 kg, and here again the temperature of this 1 kg mass of a substance is 19 degrees centigrade, let's suppose, and I am providing the heat to this substance. So this heat is absorbed by this substance of 1 kg, and the temperature increased by 1 degree or 1 Kelvin of this 1 kg of mass. I am again and again I am repeating this word 1 kg of mass. So the 1 kg of mass is very important term in the specific heat capacity. So here you may see you may say that temperature is 20 degrees centigrade now, has increased from 19 to 20, and the mass is again 1 kg. So this is called the specific heat capacity, and specific heat capacity is represented by C, and that is given by Cm over M. Here this Cm is actually what? Heat capacity. This is simple heat capacity, and this is 1 kg mass, 1 kg mass. So as C is equals to Cm divided by M, and we know that the Cm value here is del Q divided by del T. If I put this value here in this instead of Cm, so I will have C is equals to del Q divided by del T whole divided by M. And you know very well in the mathematics, if there is a denominator having another denominator, both of the denominators will be multiplied with each other. Both of the denominators will be multiplied with each other. So these two denominators will be multiplied with each other, multiplying with each other, with each other. So I will get C is equals to del Q divided by M del T, which is the final form of the specific heat capacity. Here the Q is representing the heat, T is representing the temperature, and M represents the mass. And that will be, keep in mind, that will be 1 kg mass for the specific heat capacity. And we can easily find out the unit of the specific heat capacity. So the unit of the heat is joule, and the unit of mass is kg, the unit of temperature is Kelvin. So I will write it joule per kg per Kelvin, which is the SI unit of the specific heat capacity. Okay, so in conclusion, we may say that capacity, thermal capacity, and specific heat capacity are the same things. The only difference is that is heat capacity is the raise in temperature of any substance of any mass by 1 degree centigrade is called heat capacity, and the raise in temperature by 1 Kelvin or 1 degree centigrade of a substance having only 1 kg of mass. So hope you understand these all things and the diagrams as well. So keep these all things in your mind, that the formulas and the units may come in the MCQs part. So the MCQs will be here. Simply I'm just writing here the MCQs in, like the MCQs may occur like Cm is equals to, so Cm is equals to del Q divided by del T. That is the first MCQs. The other MCQs is C is equal to Cm by M, or C is equals to del Q divided by M del T. And the unit may be also occur as an MCQs. For example, its unit is joule per Kelvin. This is important MCQs, and its unit is joule per Kelvin per kg or per kg per Kelvin. So keep this in mind that the units are different from each other. So if you have any question, you may ask now.